Hello, fellow chemists. In this video, we're going to talk about electron arrangement in atoms. This is labeled as an intermediate level video because it assumes you have a basic understanding of the atomic structure of an atom, including its electron cloud and nucleus. If you need a review of those topics, there will be a video tag in the upper right-hand corner. So when we talk about electron arrangements in atoms, really what we're talking about is where and how the electrons exist within the electron cloud. And the reason why chemists want to understand exactly where electrons exist in the electron cloud is because if you have a thorough understanding of where electrons exist, you can predict fairly accurately how an atom is going to want to react or interact with other atoms. So let's begin talking about electrons within the electron cloud of an atom. Now for this video, I'm going to actually take a cross section of this atom. So I'm going to kind of make a little triangle here. And imagine if I blow this triangle up to kind of talk about the electrons in that area. So that's what we're going to talk about here. Now, before we do that, I just want to make sure that we realize that all of the atoms that we're going to talk about are going to be neutral, which means they have the same number of protons as they have electrons. And if you have a neutral atom, then that means these atomic numbers up here, which represent the number of protons, are also representing the number of electrons in that atom. So for this video, all atoms that we're going to work with are going to be neutral atoms. So if we kind of blow up this cross section of the atom, it kind of looks like this. Now, down at the bottom is where our nucleus will exist. Put that there. And that's where all our protons and neutrons exist, and we're not too worried about them in this video. And then the electron cloud is divided into levels. So you have the first level, the second level, the third level, and the fourth level. And these are areas that the electrons can live in, just like you could have levels on the floors of a building that people can live in. Now, in the first level, these are called shells. So this would be called the first shell, or you could call it the first energy level. This would be the second shell, or energy level. This would be the third shell, or energy level. And this would be the fourth shell, or energy level. In the first shell, you can have a maximum of 2 electrons. In the second shell, it's a little bit bigger, you can see, so you can have more electrons in it. You can have a maximum of 8 electrons. In the third shell, or energy level, you can have a maximum of 8 electrons. And in the fourth shell, we're only going to talk about up to the first 2. So we're just going to put maximum of 2 electrons. And we'll put a little star next to the fourth shell and the third shell because the third shell can really hold a total of 18 electrons, but we're not going to get to that level. And the fourth shell can actually hold 32 electrons, but we're not going to go past the first 2. So if you add these up, 2 plus 8 plus 8 plus 2 gives us 20. So we're only going to look at up to the first 20 electrons that can be placed in an atom. And the reason why is because once you get past the 20th electron, the way that they get placed in the electron levels starts to get fairly complicated. So for this video, we're just going to look at the first 20 elements. So if we take a look on our periodic table, the first 20 electrons would take us up to the element calcium. Calcium is element number 20. It has an atomic number of 20, so that would have 20 electrons. So let's take a look at an example of an element and how its electrons would go into the electron cloud. So if we look at carbon, carbon has an atomic number of 6, which means if it's neutral, it's also going to have 6 electrons. So how are those 6 electrons going to exist in these different energy shells within the electron cloud? Well, there's a rule that kind of helps us determine where to put these electrons. And that rule is called the Aufbau principle. And the Aufbau principle states that an energy level will not have any electrons go into it until the lower energy levels are completely filled. So that means we have to add the electrons in order of lowest energy levels to highest energy levels. So carbon has 6 electrons. The first energy level can only hold 2 electrons. So we'll put 2 electrons in the first energy level. So there's 4 electrons that are left. The second energy level can hold up to 8 electrons. So all 4 of those other electrons will go into the second energy level. So now we've added 1, 2, 3, 4, 5, 6 electrons. That's how many electrons a neutral carbon would have. So we would say that carbon has 6 electrons. But other than just telling how many electrons an atom has, it's also important to know how many of those electrons are in its highest energy level. And carbon's highest energy level is the second energy level, or the second shell. And carbon has 4 electrons in the second shell, or second energy level. We call the highest energy electrons that an atom has its valence electrons. So we would say carbon has 6 electrons. We would also say that carbon has 4 valence electrons. Six total, 4 electrons in the highest energy level. So let's take a look at another example that has a few more electrons in it. So let's take a look at, say, the element magnesium. So magnesium is element number 12 on the periodic table, which means magnesium is going to have 12 electrons. Remember, we have to fill the electrons from lowest energy level moving up to higher energy levels. So magnesium will have 2 electrons in its lowest energy level, and then it will have 8 electrons in the next energy level, the second energy level. You can see the first energy level can only hold 2 electrons, second energy level can hold 8. So now we have a total of 10 electrons. 8 plus 2 is 10. We need to get up to 12, so the last 2 electrons will go in the third energy level. So we would say that magnesium has a total of 12 electrons. And that 2 of those electrons are valence electrons. So magnesium has 2 valence electrons. And the valence electrons are important because those are the electrons that are going to actually be the most likely to react or interact with other atoms. So that's why chemists like to keep track of valence electrons. That is it for this video. I hope you learned something. If you did, make sure you subscribe and like, and I'll see you in the next lesson.